Hi, Aidy Burrows here, and you're watching the remeshing tutorial here from the 2.8 update for the hard surface modeling course in Blender. As well as the polybuild tool, which is more of a manual retopology approach, we also have two automatic retopology methods with the Voxel remesh and the Quad remesh. Let's take a look at those and see what's on offer. Voxel remesh is not only available from the Object Data tab, it's also available in sculpt mode. I'm going to switch over to the sculpting workspace actually, which should put us into sculpt mode automatically. And then I've got our sidebar open here with the N key, which is this on the side. And we can see there's actually another remesh section right here, which is a duplication of this information. So that's pretty good for working just in one large 3D view window. So control space for me, I have it set to that default, giving us as much screen estate as possible, or at least closing out the other windows anyway. And in fact, the fact that this remesher is available within the sculpt mode probably helps explain the context and main purpose of these remesh tools. That is to say that it's generally speaking, the remeshers would be used within a sculpting workflow when evenly distributed geometry is needed. That's what we're getting here, in contrast to a manual retopology workflow where we can choose to have different levels of detail throughout the mesh. Right now I barely have any geometry here, it's just 6 faces to this cube, as you can see in the status bar down there. So if I was to try and just sculpt with the clay strips brush, for example, not a lot interesting is really going to happen here. But if I remesh using our default size there and then try that again, we can see we're actually starting to get a little bit of something happening. And if we take this detail even lower, we'll get even more geometry to work with. Almost like even more pixels to be able to get a clearer, sharper image from. Sometimes during the sculpting process, we might say grab something and pressing the F key to just scale up our brush there. I'm going to drag this bit out over there like this. And then if we just toggle on our wireframe view here, we can see that the resolution of what we have on our sculpt object is no longer even. So if we were to try and start to sculpt now, we're not really going to get the same kind of consistency and results as we might do if we were to sculpt over here. And that's not a very intuitive way to work. But the beauty of having these remesh tools is that we can just hit remesh and now we have that even resolution back again. For example, in this scene, I've just got a simple plane, which is subdivided a whole bunch of times just to create the resolution of vertices for which to paint with in vertex paint mode, and created this really basic picture. I've actually just put this decimate modifier on there. And as we reduce the ratio, meaning the amount of vertices there are on here, you can see our resolution is basically getting destroyed in some places, but it maintains its clarity in others. And it becomes pretty clear when we see the wireframe that an orderly and evenly distributed amount of geometry is going to be pretty crucial to get that consistent result. This is why I'm sure you've grasped at this point that a remesher of any kind is a pretty useful addition to the sculpting workflow. I just want to draw attention to the fact that it's only the Voxel remesher that is available here in sculpt mode on the sidebar, but we can still get access to the Quadriflow remesher from the Object Data tab. So if I go Control Space to minimize the view here, and we take a look at the remesh section, we can switch from Voxel over to Quad, initiate the Quadriflow remesh here. That brings us this floating panel, and let's just use all the default settings. You can see we've got around 3,500 faces using this Voxel remesh that we did. So I'm going to just leave that at the default 4,000 and then click OK. Allow it to just run the analysis and the algorithms it needs to be able to retopologize this. And it's given us this kind of result. So we're still in sculpt mode. It's just we had to come out of full screen mode to be able to initiate that, since it's not included on this sidebar. And also, a quick note, it doesn't look like it's done quite as good a job as Voxel did on the default settings there. So for this round anyway, the Voxel remesher wins. There are a few other differences between the remeshers, so let's take a closer look, starting with the Voxel Options. Put simply, the Voxel option is a faster and more basic algorithm. Quadriflow takes longer and will try to respect the flow, the curvature of the mesh a little more. But let's put the Voxel remesher a little more under the microscope. I'm going to come out of the sculpting workspace, pop back over to our default layout, and then delete this cube and add in a new one. We currently have a voxel size of 0.1, so if we go to Voxel Remesh now and take a look from top orthographic view, these grid lines here that we have are 0.1 units large, and so you can see that the remeshing grid that has been applied to our voxel algorithm here is 0.1. so we can easily understand this voxel size setting. But what might not be immediately apparent is the kind of direction of the grid might be quite important. So for example, let's add in another cube. I'll just push that off to the side. And then if I was to rotate, so RZ 45 degrees, and then keep that 45 degrees rotation and not actually apply it, if we just simply voxel remesh, it's going to ignore that rotation. Let's just duplicate that off. And then what I'll do this time is Control A and apply that rotation. Now if I initiate the voxel remesh and we jump into the top orthographic view, you'll notice the grid that has been applied is aligned to the world. And in this case, it hasn't made a cleaner job on the edges there. Let's take this one again and Shift D to duplicate it and bring it over on this side. And let's Control A and apply the rotation again. So if we were to do the voxel remesh on this, we're going to see how the voxel remesh is being challenged there on those edges. So I'm going to undo that with Control Z, switch over to the Quadriflow, go to Quadriflow, open up the tool, and then if we just click OK, let's see what we get. And we can see that the general flow of the faces has been taken into consideration. It's not quite perfect. You see it's a little bit on the wonky side, but generally speaking, the grid that has been applied, the resolution that we've been given for this mesh now is mostly there. Just to bring these details together, let me just create another cube. Press G and X to constrain it to the axis, bring it over, tab into edit mode, RZ45 to rotate it, tab back into object mode. This way we don't have to apply the rotation. Let's switch over to the Quadriflow remesher, click our settings, and seeing how we use this as an example, let's just quickly take a look at preserve sharp, click OK, and then we should find that once the algorithm has been finished and the remesh has been applied, that it's a much cleaner and almost perfect remesh of this cube actually. If we take a look in wireframe, we'll see that there's only minor imprecisions happening there. So something we've hinted at there with the object rotation would be similar to the object scale. So I'm going to switch off these cubes and just take a look at this kit bash item from the hard surface modeling course. And this is a very basic, very simple object. And we can see it's got a scale value of 1 at the moment. And if we voxel remesh, we can see it's not doing a very good job because it's actually quite small. So again, if we take a look from top orthographic view, we can see our grid spacing. So we really didn't have enough resolution for that. So if I go Control Z and undo it, I've got 2 options at this stage. I can scale this up. So let's tab into edit mode, select everything, S, and then let's say 10, then tab back into object mode and then hit voxel remesh again. We can see now we're getting far more details. We're getting nearly 20,000 faces. Turning the wireframe off, we can see that it's not really done a good job for this particular object. So we would probably want to take our resolution down even lower. So I'm going to undo that with Control Z. Let's go 0.01 on here. So not only have we scaled this up by 10 times, we've also reduced our voxel size down by magnitude of 10. So let's now hit the voxel remesh. And now we've got a far better representation. Here's a useful note to make about the voxel remesher, which we can do with this little spot the difference. This one is just the original mesh, and this one here is our remeshed version. And just to make it really easy, let's turn on our cavity shading and shadow. I'll just use the defaults for now. Now, aside from being able to determine all the individual, or at least the original wireframe, we can also see that this box area, this little box detail has gone. So what I'll do is I'll take this object, tab into edit mode, 3 for face select, and then Control L to select everything, G and then Z to just lift it up, and we'll see underneath that it actually doesn't have a enclosed face there. So if I deselect with Alt A, that might make it more apparent there. So let's undo that, put it back into its place, Z to switch into wireframe, 2 to get the edge loop right here, Alt left click, and then I'm just going to press F to create a face there. Numerous ways to do that. I could have just gone Control L and then Shift H to hide everything else, and we can clearly see that we've got that extra face at the bottom now. So Alt H to bring everything back, tab into object mode. I'll create another version with Shift D to put on the left side of it. And on this one now, we'll run the same voxel remesh, and we'll notice that this time the box has been taken into consideration. Alright, so just to drill the point home, I'm back in the land of the cubes, and let's see if we just add another one here, and then this is just going to be a very simple intersection. Just Shift D to duplicate and just raise it and have it overlapping by about 1/4 of its volume there. Nothing too crazy. But if we just shift select them both, Control J to join them, and then press Z to take a look in wireframe mode, you can see that nothing fancy has been going on. This is just two intersecting cubes. No interesting Boolean operation has taken place or anything. But if we take our voxel size and just make that slightly higher actually, just to make the wireframe really easy to read, and then hit voxel remesh, we might be able to see it has attempted to create a kind of Boolean really. I'm going to tab into edit mode, just select with Shift G all the faces on this side, and then hit H to hide. We can take a little look inside and we can see that no longer are just simply two cubes overlapping. It of course seems a little bit crude because we've set our resolution down so low, but if I was to just undo a few steps and take the resolution down a little bit instead and then reperform the voxel remesh, we can see actually we've got quite a tight join there. And if we right click to shade it smooth, it might act even as a little welding seam between the two cubes. So the overall lesson here is that non-watertight meshes are welcome here for the voxel remesh, and overlapping geometry, parts of it are going to get thrown away for a kind of continuous shell that can be seen. It won't really have hidden parts. To deviate from the land of cubes into the exotic land of the plane, let's just take a look at this one, and then I'm going to voxel remesh this. Now it might look like everything worked there, which might be surprising because a single plane isn't really a watertight mesh or anything, but we can see that with our back face culling on, that actually you can still see both sides. And if I tab into edit mode again, select a face, do that same trick, Shift G coplanar and G and then Z and lift that up, we can see the additional trouble that we might get into with geometry that isn't watertight like a cube. As we saw in the kit bash example, where the box that we had here wasn't coming along for the ride since it had its bottom face missing, despite it being overlapping with the rest of the mesh. Here I've got a pretty basic object. If I just remove the wireframe for a second, you can see that it's all hard shading. Let's stick a bevel modifier on this, set it to angle, take another look at the wireframe actually, and then increase that there. If we were to come over to our remesh now, just note that it isn't going to take this modifier into account. So if we voxel remesh, you can see it looks completely different afterwards. Let's undo that with Control Z. First, we would need to apply our modifiers. We could do that a number of ways. We could just hit apply there, or we could come to our object menu and convert to mesh. With that done, now when we come to our voxel remesh, it's going to try and incorporate more of that beveled shape there. Since we locked it in, we baked it in. Again, I'll undo that though a couple of times so that we can get our bevel modifier back. And then I'm just going to remove it. And then I just wanted to make a little bit more of a note on these edges that I've got. Toggle the wireframe off again. And what I could do is hit shade smooth, come over to here, and with our normals, hit auto smooth. And now it looks like there's a nice smooth curvature. This is just a trick of the light. The actual polygons are quite noticeable. If we were to take a look from the front orthographic, for example, we can clearly see the stepping happening there. And when we're going to remesh, that stepping is going to become more and more apparent. It's kind of like if we were to 3D print this out. Again, in the real world, we wouldn't have this trick of the light. It would look low poly in the real world. So if I just set our resolution down a little bit lower and go to voxel remesh, we can see that low polygonal structure much more noticeable. And I guess if this was a real 3D object, you'd probably just try and polish that out with some good old-fashioned elbow grease. But for now, we can kind of use some blender grease, if the metaphor carries, and just make sure to use way more polygons, basically, to try and get the job done. Hopefully now when we remesh, it's not quite as apparent, and I think we can just about get away with that. One last thing concerning watertight meshes, using the voxel remesher. To demonstrate, I've got this other kit bash item. I've just colored it a little bit blue and then set our color here in the viewport to object. So let's come over to the Object Data tab and get ready to give this a voxel remesh. First of all though, I've scaled it right up, so I'm going to apply the scale, and then let's see what happens if we just do it right now. Alright, so we know this isn't working quite right, and part of the reason will be because it's definitely not watertight, but it's not just this obvious area here. There's actually another less obvious area right here. So I just wanted to discuss a quick way to find those areas, those potentially problematic areas. I'm going to switch to edge select mode here and then select all by trait, non-manifold edges. And let's use Z to take a look at our wireframe here. That's a problem area. We've got that area that we've already looked up. And also we've got the bottom of these kind of bolts and nuts that we've got. So all I'm going to need to do here is just press F and that should just close everything off all in one go. Just to make this a little bit neater here though, I'm going to switch to 3 for face select mode and then just extrude that out with E, then maybe I to inset that slightly, maybe give that an extra loop just there actually. And with that done, let's see how the voxel remesh does. Alright, so it's a little low resolution, but we've definitely maintained the majority of its shape. So I'm going to undo that with Ctrl Z. Let's take that down to 0.01 and try that again. And that looks way cleaner now. The only issue that we're getting, as indicated in the previous example, is just the low poly nature of the object starts to become a little bit more apparent. Here I've got that same object and I've remeshed it in 2 slightly different ways. I've set the voxel size down to 0.05, and on this one we don't have the fixed poles option selected, and on this one we do. So let's just take a quick look at the results. The major difference between the two is on this one we barely have any of these diamond junctions. And if we look on here, we've got tons over on this area and the several dotted through and across the top as well. Whereas on this mesh, it's tried to be a little bit more reserved when it comes to placing poles everywhere, hence the fixed poles. Taking a look at the preserve volume option, here I've got 3 separate objects. Each object contains a cylinder and a cube. This is the input mesh. This is the one with the preserve volume checkbox on, and this one is the one without. Now I've given them slightly different colors, so we're looking at material colors on here now. The cubes have got a gray and the cylinders have got a darker color. And you can see on this one, which isn't preserving the volume, the cylinder especially has kind of shrunk in a little bit, especially on the edges, and is revealing more of the cube at the back there. They're both pretty much the same size. This one is 4.84 meters wide, or deep, if we're looking at it from this angle, but these two are the same. But generally speaking, you can see the shapes are holding a little bit better when the preserve volume is checked. That goes for the cube as well. You can see that here the cube is being rounded out a little bit more as compared to this one, which is preserving the volume. This generally gets more and more extreme depending on the voxel size, but in general it helps to have a more accurate result, so leaving this on is a good idea. Just to drill the point even further and actually make a new point as well, let's duplicate this non-preserved volume remesh and let's do that again. Just remesh again, and we can see that it kind of contracted even more. So I'm just going to undo that and this time preserve the volume and do that again. And we can see it did a much better job. But instead I'm going to undo that and also show the smooth normals option at the same time. And this is a really simple checkbox. It's basically just going to smooth the normals for us. So as we do that now, and I take off the wireframe, we can see while these remesh examples are still flat shaded, this one is now smooth. Just note it isn't set to auto smooth in our normals there. This is just right clicking and shading smooth essentially. Let's take another duplication of these simple primitives that we've got and then take a look at this other option here, Preserve Paint Mask. Now I think this is probably going to get renamed at some point since this is a little bit misleading as it's not talking about anything to do with our texture painting. Coming over to our Tools tab and adding some simple UVs and adding in a base color, just scrolling down a little bit, you can see that within here we do actually have a mask or a stencil option within our painting, but instead of that it's actually referring to the sculpt mode. So when we come over to sculpt mode, I'm going to open out our tools so we can read them here, and if we scroll down a little bit you'll see that we've got one called mask. And as we take this and start to paint, we're painting a mask, meaning this area isn't going to be affected when we go to do some sculpting. It might not be as well contrasty as it could be there, so let's take this black material here and make it much lighter so that we can make out our mask even better. And now if we come over to the remesh settings and enable the preserve paint mask, which probably should say sculpt mask, what I'll do is take this voxel size down a little bit so that we can see more of a change when we come to remesh. Then we'll hit the voxel remesh button. And then we can see after it's finished remeshing, we still have our sculpt mask preserved. I'm going to switch off this Kitbash collection and ride back into Cube Town, and let's go and add in a fresh cube and take a look at our remesh settings. All I want to demonstrate on this is the adaptivity. So the first thing to note on this is that as soon as we raise this up, anything past 0, it's essentially going to switch our fixed poles off. Perhaps that should be grayed out actually when this value is above 0, just to make that clear. So what this adaptivity is trying to do is just preserve detail where it needs it, so on the corners in this case, and in the middle of the flat faces it's going to try and reduce or decimate some of those polygons that aren't really contributing to the shape, therefore giving us a lower poly count overall. So let's just take this with 0 just to remind ourselves what we get, and let's toggle our wireframe on. So this is giving us around 2,500 faces. And as soon as we try and add some adaptivity into this and try again, we can see in the center of the faces we've barely got any additional polygons there, and our poly count for this cube now is under 1,000, so 4 times less. I'm going to drop this even lower, 0.01, and drop this higher, 0.2, and see what we get. And now we've got quite a lot of geometry right where the faces are turning corners. Let's try and take this even higher, like 0.5, and we'll do another remesh. Basically, the higher this value goes, the lower the poly count should be. And a quick note, we're locked out at a value of about 1 meters. Lower details, for example 0.01 in this case, means that basically more detail is going to be kept and therefore a higher poly count. With hard surface models, I can't say I've had a lot of usable results with this, but it's definitely worth knowing that it's there. Probably a little bit more suitable for applying that with more organic shapes. Let's take another look at this particular object again. Let's make it more readable by turning on our shadow and cavity options in the viewport. And I'm going to toggle the wireframe on this. So let's just duplicate this out with Shift D and take another look at this one. Do a simple fix poles, preserve volume, which should be its default. And to preserve some of the more smaller details, I'm going to take the voxel size down to 0.01. And then we'll just hit the voxel remesh button. Keep an eye on the box. We can see there's a little bit of an issue there. Let's come over to this one. As we remember, we actually capped the underfloor of this box to make it work in voxel mode. Let's take a look at quad mode instead and go Quadriflow Remesh and use the default settings and click OK. Now it doesn't look too great at the moment, but it has preserved the box. Something else to bear in mind, if we take a look around here, we can see that this cylindrical part here seems to be attaching to the main base of the object, which it isn't normally, which it actually shouldn't be. And if we take a look at this version, you can see that the Quadriflow remesher, it hasn't struggled with separating that geometry there. Plus, an extra bonus is that it's thrown in the box for us, so the non-manifold geometry and intersecting and overlapping parts are kind of preserved here. So if we take a look at this section and just lift it up, have a look underneath, and we see it still has a face missing at the bottom there. So while Quadriflow can be way slower, like 20 times slower to get the same amount of polygons, it can actually yield better results, as this is going to allow us to set a polygon target, as we can see here, and generally does a better job at following the geometry. It's going to accept planes and non-watertight meshes. Let's just try that out with a mesh plane here. In fact, tab into edit mode, Shift D to duplicate it. Let's rotate that on the Z axis just to give it a little challenge. And then take this object and let's go over to the Quadriflow, and then let's just choose default settings and click OK and watch it work its magic. Let's take a look at the wireframe on this, and that's done a good job of figuring out the orientation of the planes there. Plus it hasn't created any kind of additional geometry underneath, like attempting to convert these planes into kind of squashed down boxes or anything. Let's put the settings for the Quadriflow remesh under the microscope a little bit. So we've got this use paint symmetry. Again, that isn't texture painting or vertex painting or anything like this. We even have mesh symmetry that you can see up at the top there when we tab into edit mode. But you'll notice that both remeshers here are grayed out while in edit mode, so we can't be in edit mode to initiate these. The symmetry that it's referring to is going to be found in sculpt mode, which again is basically in the same kind of place there. So at the moment here I'm set to the X axis, so it's going to copy what's on the left side here and throw it over onto the right. So essentially what we're saying here is that this should be actually a symmetrical mesh, and if we do happen to be working on a symmetrical mesh, which is quite common while sculpting, we're basically saying to the algorithm you only need to do half a job, and then once you've done half of it, just copy that to the other side. So it's a way to speed up the process here. So if we click OK and see what kind of result we get on this mesh, we can see we're now left with a symmetrical mesh along the x-axis. Our next setting is the preserve sharp option. Here's a simple input mesh, the super basic cube, and over here we have the results of preserving sharp, and then on this one I've turned that off. And as you can see, if we take the wireframe off, we're having quite a bit of an issue around some of the sharper areas there. So clearly with a more hard surface object, that preserving the sharp is going to be the way to go there. Taking a look at the preserve mesh boundary option here, this is the input mesh, simple cylinder with just a hole cut out of the side. This is the result of preserving the mesh boundary. This is the result without. You can see the result of the geometry created around this mesh boundary is pretty poor on that version, especially when compared to this version. It's not perfect, but it's definitely way better than this version. Let's take a look at the next setting. Using this as an input example, this is our first result. Now what's happened here is we've got preserve sharp set, we're preserving the mesh boundary, use mesh curvature was also enabled for this one. And if we take a look around the handles area of this, we can see that the flow of the polygons are turning a corner there, which is looking pretty good. And then also on this object, this didn't have the use mesh curvature setting enabled, and we can see that it's not really turned quite as nicely on the corners. And especially here at the back has been particularly troublesome compared to this one, which was following the mesh curvature more closely. The other two settings, this preserve paint mask, is talking about the sculpting mask again, as we've already discussed with the Voxel remesher, and that would go for the smooth normals as well. That's going to give us the same results as before. The only other thing to discuss is that by default we're set to faces, so we can set the amount of faces that we have as a target that we want the remesher to reach. We also have a ratio. A ratio of 1 is going to use the same amount of faces that it already has, and 0.5 would be half of the amount, and 2 would be twice the amount. And as a mode, we also have the edge length option, which is the option both of these objects used with a value set to 0.1, which is able to predict the amount of faces that it's going to use. So the higher we make our edges, the less faces are going to be able to be produced. And obviously it's going to look way more low resolution. And then finally, we have our seed. So if we feel a result is very, very close, but not quite there, we can always try a different seed and see if it nails it that time. So that's what version 2.81 has brought us in the remesh department, but it probably would be a disservice to the subject if we were not to mention that we've had a remesher modifier for a while, which is what we have here. We can find that easily enough right here under remesh. There's a few basic modes. There's the blocks mode, which is more of an effect than anything, but it's a very cool effect. We have the smooth algorithm, which is kind of rounding out corners. And then we have the sharp option, which is probably better for more hard surface things, preserving those sharp corners. And we have the octree depth and the scale to basically determine the resolution and fine tune it. And we can decide whether to have it smooth shading or not. I think it's also worth remembering that with the modifier, it allows us to be non-destructive, and it's actually very easy to animate. Finally, to round things off, let's take a look at some other remeshers available. Probably one of the current best options out there, which is actually available as a paid add-on within Blender, is Exoside's Quad Remesher. They have loads of examples and further details on the site. If a remesher is something you really need for your professional work and the Blender default options aren't cutting it, then definitely worth a look into this. Over on the Blender market, there are some further options such as Dyne Remesh and Autoflow from Alberto FX. This has a lot of interesting, useful and easily controlled features. Another on the Blender market is Tessellator from Flow Tools. Interestingly, the add-on uses a particle system that can be guided by the grease pencil to inform the end results. A few free options include IGL, MMG and Meshlab. It's possible to get a quick feel of those and how a couple of those compare on this demo page for the Quadriflow remesher. You can choose an input mesh and then specify the algorithms to see how the results differ. So that should wrap us up for what 2.81 brought us in regards to remeshing. This is Aidy Burrows and you've been watching the 2.8 update for the hard surface modeling course in Blender.